That is something Santa would say. You gotta write down the word. I feel it. Am I right?
All right, we are going to start Unit 5 today, just briefly. Okay, we're just going to have time to do the whole first section today and tomorrow before break. And I think that this section is going to be pretty simple for us because it's basically a continuation of what we've been doing with derivatives, maxes, and mins. Okay, kind of sign chart ideas. So this section is going to be pretty simple. What I do want to go over, though, is the winter break packet that I gave you. So over break, because it's nice and long this year, I need you to keep the content fresh. Okay, we have 16 days without seeing each other, and who knows what can happen to your brain in 16 days if you don't look at calculus. Okay, so it is my worst nightmare. Yep. So what I thought of was, instead of making you do a project or worksheets or something like that, I've decided to essentially give you a take-home midterm. So instead of having a midterm in here after break, I'm letting you take questions home. You can use each other. You can use the internet. You can use your notes. You can email me if you want to.
So there should be no reason why we don't get 100%.
Exactly. No reason you shouldn't get 100%. Okay? So some things I know you can read, so I don't want to completely insult your intelligence, but there are 7 things that I want to go over about this kind of take-home midterm. So I need you to be extremely organized. These are all free response questions, which means you're going to have to show your work and write some justifications when it asks you to do that. So please write neatly. Okay, when you take the AP test and the graders look at it, if they can't read your handwriting, they're not going to give you credit. So you really need to make sure that you can write neatly and efficiently. Like I said, for number 2, you can use your notes, you can use each other, you can use the internet, you can email me. Okay, so you have all those resources. I will be collecting this back the day we get back from break, which is Monday the 6th. Okay, so actually it's 16 days of vacation, but since I'm giving it to you now, you actually have more. So I think it's about 20 or so, maybe, somewhere in there. So you basically have three weeks to get this done. I'm going to count this as a test, but it's not going to be according to the curve. You know how if you turn in your homework, you get that curve grade? Okay, there's no homework for this, so you don't get the curve, but you get to use your notes, you get to use each other, so there's some help there. The kind of kicker, I guess, to this is for number 4. We're going to have a pop quiz someday that's going to include 2 of these 10 questions. It might not be the exact 2. They'd be very similar in nature, but you're going to have 2 of these 10 questions for a pop quiz someday, which is going to count as a quiz. So I know you get to use your notes, I know you get to use the internet and each other, but you still need to be held responsible for knowing the content. So it's going to count as a quiz grade, which isn't as weighted as much as a test, but we're still going to, you still have that individual responsibility in the future. Okay, pop quiz at some point. So going on the honor system for number 5, you should be able to do all of these without a calculator, except for number 10. So you can use a calculator for number 10. Since they're free response questions, they really shouldn't take you more than 15 to 25 minutes, but depending on if you need to use your notes or use the internet, it might take a little bit longer if you use those resources. So roughly 15 to 25 minutes. And number 7, I think it's the most important one. When you reach the point that you're cursing my name over winter break, I need you to remember that I wouldn't be doing this unless, or if I didn't think it would be beneficial for you. Because I know I want to enjoy break just as much as you do, but like I said, we can't lose this content. Okay, so we got to keep it fresh somehow. Yeah.
Could we use a calculator to check an answer?
Mm-hmm. Yep. So Am I going to know if you use a calculator or not use a calculator? Probably not. But, okay, on the pop quiz in the future, you probably will not be able to use a calculator. So make sure you can do them without a calculator. Okay? All right. So do the day we get back from break. If you want to do all of them before break happens, you do that. You can wait till the day or the day before we have to come back. That's okay too. Okay? But I would treat this as a marathon, not a sprint. So it's a sprint. The last day. Some of us are procrastinators. By the way, the grading is at the bottom. Just like every free response question in here and on the AP test, it's worth 9 points. So you have 10 questions, 9 points each, going to be at a 90. Okay? And then straight percentage, no curve. All right? Deal. Let's go ahead and take a look at our next section, 273. We're going to take a look at something called the extreme value theorem. All right, you may have to move your desks so you can see. I know they're in groups because we're doing a free response day in pre-calc, but you might need to move your desks. So what we've been talking a lot about this year are maxes and mins, like how we can identify a max versus a min by utilizing a sign chart or those critical points. But we've also talked about, at least in pre-calc last year, there's a difference between some maxes and mins. You could have what's called a relative max or min or an absolute max or min. Can we remember or distinguish perhaps the difference between the two? It's a one-word difference, but they mean something completely different in terms of a graph. Yeah?
This is half of a guess.
Half of a guess, okay.
It means any like turning point,
Mm-hmm.
and the other one means the total max. So the highest point, the other one's the lowest point.
Right, absolute. Okay, so relative is any, I don't want to say, I understand what you mean by turning point, but is that a turning point?
Let's go.
You change direction, right?
Change of slope type of turning point. Oh, wait. No, that's not what I meant. That's not what I meant. A plus to minus.
For the derivative. Okay, so any,
I know what I'm saying.
I know what you mean, but I'm trying to make you be specific here. Okay, so any location where a graph changes, if the derivative changes positive to negative or negative to positive, what does the original function do? Changes, that's second derivative. If the first derivative changes positive to negative, negative to positive, the original function changes.
Oh, so his answer. His answer.
Say it now.
So then you don't say it out loud. It's okay.
Say it now.
Did he say increasing or decreasing?
Yes.
Yes, okay.
No.
Changes increasing to decreasing or vice versa. So like, Christian, I know what you meant, but I'm going to be a little bit,
Completely all right.
okay? So any location where a graph changes increasing to decreasing or decreasing to increasing. So absolutely any point. Absolute, on the other hand, like Christian said, is the highest or the lowest point. So we'll say the highest / lowest, maybe we'll just say point. All right, so we're just going to practice identifying the difference between these maxes and mins. Relative is any location. Absolute is one specific location, the highest or the lowest. So let's go ahead and try maybe this polynomial one first. Can we find coordinates of relative max or mins? Any location where a graph changes increasing and decreasing or vice versa. Okay. Negative 3, 0. And can we classify it as a relative max or relative min? Minimum. Okay, decreasing to increasing. So I'll say R min for abbreviation, relative min. Can we find another point? All right, relative max or min? Relative max. Okay, we change increasing to decreasing. Any other spots? Good, Griffin?
2, -6.
2, -6. And what's that type?
Min.
Relative min. All right, decreasing to increasing. Looks good. So those are any point where, and graphically, they kind of look like tops of mountains or bottoms of valleys, okay, visuals that we can look for. But by definition, we're changing increasing to decreasing or decreasing to increasing. What about some coordinates of absolute extrema? So can we pick the highest point or the lowest point? What do you think, Austin?
2, -6.
2, -6, and that is an absolute
Minimum.
min. Okay, so I'll do a min for short, but absolute minimum.
So the relatives can be maxes, but the maxes can't be relatives.
The relatives can be absolutes,
Yeah,
but the absolutes are relatives,
yeah.
but the relatives are not always absolutes, right? So notice how this absolute was a relative, but these other relatives are not necessarily absolutes. Kind of like all squares are rectangles, but not all rectangles are squares. Okay? Do we have an absolute max? Can we pick the highest point that this graph reaches?
No,
Why not?
because it's increasing.
It's increasing on both sides, right? So if it's increasing forever, will you ever reach the highest point? One highest point? No. Okay? So no absolute max. Okay. Let's go ahead and take a look at g of x. It's not necessarily a polynomial. We don't have smooth curves going on here. They're more jagged, sharp points. Can we find relative extrema, relative maxes and mins?
-3.
Yep.
-4.
Good. Okay, relative
Min.
min. We change decreasing to increasing. Good.
Dude, I want you to go. I already went twice.
This is the easiest.
I actually went
class
3
ever.
times. No, like I know this. Right?
Bless you.
3-2.
3-2.
Another min.
Another relative min. All right. And then -1, 4. Relative max. All right. Low point, high point, low point. We have that increasing to decreasing or vice versa change. Looks good. What about absolute? So the highest point or the lowest point? Go ahead, Anuj.
I'll leave one for Stu. Is 6, 5 the absolute max?
There we go. The highest point
So it can be.
that this graph reaches.
Stu, I literally gave you the answer. She's smiling, so she knows it's right. -3, -4. Absolutely right. -3. You already wrote it down.
Leave the poor boy alone. All right, -3, -4, absolute min. Okay, so like Austin said earlier, this is kind of leading us into a way to determine where an absolute max or min might be located. So on a domain, okay, we have some type of interval. It could be all real numbers. It could be a little section. Did the absolute extrema occur at a relative location? Okay, so the first one, 2, -6 was an absolute min, and notice how that was listed as a relative. Okay, 6,5 was listed as an absolute max, but it was not listed at a relative. So it could be, but it doesn't always necessarily have to be. We're going to talk about the difference. Notice how this graph had a domain of all real numbers. It could go forever each way, but this graph was finite. We go from -5 to +6. So that finiteness to the graph might dictate where this absolute max happens. It might not be at a relative spot. So we'll say an absolute max/min could happen at a relative location, but doesn't always have to. We're doing okay? All right. Let's try some more. So I think we have the same graphs, but now we're going to take a look at perhaps different domains. So this was the f of x graph we had before, but now we're just going to focus on this little interval of the graph. So if we only look from -2 to +3, so maybe I'll go ahead and show those dots. So right here and right here. We're just looking everything in between there. Can we find some absolute extrema? Can we find the highest point, the lowest point? Good, Anish?
Is -1, 3 the absolute max?
Yep. Okay, so on this little interval, we don't really care about the rest of the graph, but on this little interval, that's the highest spot. Looks good. What about the lowest spot? 2, -6. Absolute min. Good. Okay, so we're going to take a look at the same graph for the question underneath it, but notice how we're going to switch up the interval. So now we're going to go from -4 to 1. Okay, we only care about this little section now. Can we find absolute max, absolute min? Good, Anish?
Is -4, 4?
Yep. Yeah, we'll say it's roughly there. And then, do we have a lowest point? One -3, good. Okay, so take a look. We're dealing with the same graph, right? It's still f of x, but when we switch the interval that we're interested in, it can change where the absolute max and min are located. Okay, notice how before -1, 3 was the highest point, but in the next interval it happened to be the lowest. So the interval is kind of important where you're looking for on the graph. Okay, so that finiteness is something to pay attention to. Let's try g of x. So instead of looking at the whole thing like we did before, we'll go from -4 to 5. Okay, so just that section. Can we find absolute max, absolute min? Okay. Absolute max. So is 5, 4. Okay, so you can have 2 points. Notice how they have the same height though, right? The same height of 4. You could have multiple points at that same height, but realistically, I guess the highest value you reach is 4. Okay, so you can't have more than one point, that is. It's the same height of 4. What about the absolute min? -3, -4. Looks good. All right, let's switch up the interval. Same graph, different section. -2 to 6. Absolute max, absolute min.
Come on, Stu, you got it.
He's getting old.
-2, 0.
-2, 0. I put that in the wrong spot. That's our absolute min. And then our absolute max.
I don't know. Maybe finish your question and find the answer.
6'5".
6'5", good. Okay, so if we take a look at these examples of these absolute maxes and mins, we're going to try to find 3 places where absolute maxes and mins could happen. So let's take a look. Maybe on f of x, we'll go back to this first interval, -2 to 3. Okay, this absolute max happened here, whereas this absolute min happened here. So where are these points?
Max and mins.
They are like clearly max and mins, like the top of a mountain, the bottom of a valley, right? And if you have a top of a hill or the bottom of a valley, you know your slope is 0, right? So the derivative equals 0. If we go for the g of x graph on our first interval, -4 to 5, -3, -4 was an absolute minimum, and then we had this absolute, or these 2 absolute maxes, I guess. Now, this is a minimum, a relative min, but does it have a horizontal slope there? No. What is the slope at a sharp point? Undefined. So the derivative could also be undefined. What are these called if the derivative is 0 or undefined? Critical points. So a cusp is the same thing as a sharp point. Okay. That's okay.
We're all friends in here, Stu.
Critical point. Okay, so absolute max or min could happen at a critical point where the first derivative is 0 or undefined. We've kind of already seen that this year in our sign chart, right? But we also have another case. What if, let's see over here, this 5, 4 we labeled was another absolute max. Now this is not the top of a mountain or the bottom of a valley. What is this point?
Endpoint.
It's an endpoint for this specific interval. Okay, so these 3 things are leading us into a very actually important theorem in calculus called the extreme value theorem. Extreme meaning maxes and mins, those high points and low points. And just like we talked about the intermediate value theorem at the beginning of the year, we can abbreviate this one EVT for short if you want to. So this theorem is telling us if a function is completely defined and continuous on a closed interval. Okay, that means you have endpoints, closed endpoints at each end. Okay, if you're completely defined and continuous on a closed interval, then f of x must have an absolute max and min at a critical point or endpoint. Okay. So if you have a graph that goes from endpoint to endpoint, okay, no holes, no jumps, no nothing, in between, you are guaranteed to have a highest point and a lowest point. And it could either happen at a critical point or an end point. That's what we've kind of seen in the last few examples. Okay, extreme value theorem. So completely defined and continuous on a closed interval. You have a specific beginning and ending point. If we think about I'm going to cover this up just for a second. I know you might be writing. If we think about this example that we did on the front page, okay, where we didn't have a defined interval, we said it was negative infinity to positive infinity. Notice how we did not have an absolute minimum. So the only way you're guaranteed to have a high point, the highest point, and the lowest point is if you have a closed interval, okay, not domain of all real numbers. So if that's the case, we're going to have to check those endpoints. Okay, so this is called the extreme value theorem. Let's see if we can apply it. Okay, on the next page. Consider the function to answer the following questions. Determine the intervals where f is increasing and decreasing. What do you want to do? Let's find some critical points. Okay, so first derivative, negative 3x squared minus 12x minus 9. Is that quadratic equation going to be undefined anywhere? Any whole or asymptote we have to worry about? Not on a quadratic, right? That's a smooth U shape. Okay, but we also need to check where the first derivative is 0. So if we set it equal to 0, how do you want to solve for x? Factor. Maybe we'll take out a negative 3. Can we think of two numbers that multiply to 3 but add to 4? 1 and 3. So critical points, negative 1, negative 3. All right, let's make our sign chart. Anything between negative infinity and negative 3. Maybe negative 4. If you plug it into your factors, maybe that might help you a little bit more. We're going to have negative 3 times negative 3 times negative 1. Negative. If I plug in negative 4, that's what I would end up with. Something between negative 3 and negative 1. Yep, we'll use 0 for the last one. We'll do negative 2. So this would be negative, negative 3 times negative 1 times positive 1. Negative times positive. Positive, right? And then we'll do 0 for the last one. Negative 3 times 1 times 3. Negative. All right, so increasing negative 3 to negative 1 because derivative is negative. Decreasing negative infinity to negative 3, but also negative 1 to infinity because derivative is positive. All right, that's a review question. Let's do B. Determine the coordinates of relative extrema. So any high point, any low point, where we have that increasing to decreasing or vice versa change. So can we, based off of our sign chart, determine where a minimum or maximum might be located? Min at negative 3, max at negative 1. Okay, but they want the coordinates, meaning x and y. Oh, no, we can do it. We'll say because f prime changes negative to positive, because f prime changes positive to negative. All right, so we got to figure out if we were to plug in negative 3 into the original function to figure out where its minimum would be. Okay, not absolute minimum, just a regular minimum, any low point. Can you trust that would be 2?
Sure.
Can we plug that in eventually? If I tell you it's 2, do you believe me?
Yeah.
Yeah, okay. If we were to plug, we might be able to do this one. If we plug in -1, this would be +1 minus 6 plus 9 plus 2. One minus 6, -5 plus 9, 4 plus 2, 6. There we go. Looks good. All right, let's keep going. Pictured below is the graph of the function f. So the equation they gave us at the top, this is what the graph would look like, but only on this little section from -4 to 1. So notice how we have a closed interval. We have closed circles or endpoints on the beginning and ending spots. So identify the absolute max on this interval. Can we find what the highest value or the highest point would be? So -4, 6, and also there's another one? -1, 6. Okay, so we'll say the absolute max value. Okay, there's a difference between point and value, the terminology. Point means x, y. Value is a number. So what is the absolute max number we have? 6. That's your height. Okay, is 6. Okay. Let's go ahead and do absolute minimum on the same interval. One comma -14. Okay. So absolute min value is -14, right? That lowest point.
No, it's the -1. It's -3, 2.
It's the interval is from -4, -1.
Facts.
So then it'd be.
Oh, I thought it said +1. Look at you guys. Yep, right there. Look at you. All right, so that would be -3, -2. Good catch. I don't know. Oh, I guess because the next two deal with that. All right, so on that interval, good catch. Good catch, good catch. All right, on that interval, the absolute minimum value would be -2. Okay, but now we're going to switch it up for the next one. So different interval. This time we are going to go all the way to 1.
It's positive. It's okay, Miss Bauer. We all have those days.
I know. Today's one of them. Today's one of them. Can you, here. Do you want my pen? You can come up here.
No, Mike.
Do you want to do the last
I
two?
just feel good.
That's good.
Like, any other day I'm lost right now, but like I'm on
Oh, all right. What about maximum on this -4 to 1 interval that they actually give us? Is it the same points?
Yes, it is.
Okay, so I'm not going crazy. Absolute max value is 6. What about the absolute minimum? 1, -14. Okay, so absolute min value is -14. Okay, so again, okay, they tripped me up. They caught me. I missed the negative. Notice how if the interval changes, so might the absolute maxes and mins. So the maxes stayed the same, but notice how the absolute min changed because the interval changed. So you have to be careful with those endpoints. Okay, where are they located? We doing okay? I know Austin is. Okay. We're going to stop there for today, and we'll do some other examples tomorrow. More calculus based.
I'm starting to pack it, all right?
Like I'm